Hey, welcome back to Barry T's Garage, and I'm Barry T, and today I have Alan to answer some of your questions. Alan's got a variety of basically pre-World War I cars, and we've had a lot of fun learning about them, and I have a feeling we're going to learn a little bit more today. So, hey there, Alan, welcome.
Hey, Barry.
Good to be in your garage on Barry T's Garage. It's all good.
Yep.
All right. Okay, Alan, well, we're going to go straight to it. We have someone that watches quite a lot and comments often. His handle is 2packs for sure. So I don't know. But anyway, he has a question we'll start off with. It says, basically, what mechanism drives or activates the oil dripping system in the 1907 Renault, which happens to be right behind me there? Because given the fact that the drippers are inactive when the engine's off, but how does it get started? What functions then?
It actually has a mechanical pump that pressurizes the oil dripper tank.
It does?
Yeah, it does. Most of the other cars are only by gravity. The problem with the only by gravity cars, which is still half of them that are in here, when it's cold or hot, or vibration or no vibration, or vacuum or pressure by the engine running, the flow can change dramatically.
Right.
So the Renault, since it was a race car, I mean a real serious, 500 cubic inch plus 4-cylinder, it had pressurized oil to the drippers. It's still going through the drippers, which is a restriction.
Yeah.
But it's got a pressure to that flow. So no matter if it's hot or cold or the engine's running with vacuum or pressure, it's still delivering the oil about the same time, about the same rate.
All right. Well, that's a good question. I never thought to even ask that.
Yeah. Well, they're all different. They're all different. But that's one that's really serious on all of they spent a fortune making sure that everything was absolutely extremely well thought out on that Renault.
Wow. Very good. All right. Well, the next question is, could reducing the oil supply to the cylinder on the Sizaire engine, could that increase the risk of piston seizing, considering already very tight tolerances there?
Hopefully not. I mean, it's still a giant bore, so it's still going to have some leakage. Okay. You start it when it's cold. So since it's a large bore, you leave a lot of leeway in the ring gap. And you still leave some room in that ring gap. Hopefully not. Yes, I put a PCV valve type item on there, or just a ball valve, so I had more of a vacuum in that crankcase instead of more of a pressure. So hopefully drawing that oil through the oil ring. Yeah. I think it's going to be probably fine. And also the engine's going to fill up faster because it's not going to be burning the oil. So there's going to be more oil in the bottom of the sump, whereas before, without an oil control ring, I had to drain it every 30 miles, the crankcase, because otherwise it would just really go past the non-oil ring. Yeah. So now I can go 100 miles. So I think there's some pluses and some minuses, but I think it's going to still be fine. I'm certainly going to watch it. Yeah.
Well, one good thing about that car is, by my observation, it's not that massive a job to kind of get into it a little bit and check it out.
No, it's not.
So
in a couple hours, I can have the engine tore apart.
Yeah.
And in 3 hours, I can have it all back together again.
So yeah. So not the end of the world.
No.
Some cars don't take almost that long just for an oil change nowadays.
Yeah, I know.
Someone named Gregory is asking, is it feasible to modify the crankshaft, camshaft, and magneto drive bushings of the Sizaire engine by machining grooves to accommodate, oh boy, elastomer seals such as lip seals or O-rings, and transition back to splash lubrication using an oil control ring and rod bushing pin? Wow, that's getting pretty deep engineering for me.
Well, some of the crankshafts you can do that with. Okay. Some of the crankshafts past the final area that would be inside of the bearing would have a diameter larger because the crankshaft is doing something else, either a conical shape for a flywheel or a drive. So sometimes you just can't do it to put a one-piece seal on.
I see.
So since the engines are so different, and since the configurations of the both ends of the crankshaft and camshafts are different, the most important and most common thing they did back then was put a spiral in the opposite direction the crankshaft was turning to kind of bring the oil back in. And then they would wrap on the outside, as farthest outside of where the bearing was, with a rope, just a hemp type rope seal, and that would kind of keep the oil into. That's what they did.
Yeah. Okay.
We have put seals on one or two cars in the last 30 or 40 years that we could actually do it, but most of the time you can't.
Right. Just it's inherent in the design. The way
because it gets larger than the journal size outside of where the bearing goes.
Okay. Yeah. Okay. Cool. Well, it's still a good question. All right. Another one. Would installing a small oil pump and filter to clean and recirculate the oil to the reservoir, operating maybe intermittently for 30 or 40 seconds every hour, be a practical enhancement for an engine like that?
Well, but there's only a few places that the oil goes to, and there's basically, consider both ends of the camshaft or both ends of the crankshaft in most of these old cars. Yeah. There's kind of a funnel. The funnel in the system. Yeah. So as it's doing the splash, that splash fills up those funnels on both sides, which might be, the mouth of that funnel might be 3/4 inch diameter and leads to a drip rate of 10 drips per minute or something. If you had a pump that was plumbed into that line, it would blow out the top of that funnel. Instead of going into the bearing. Yeah. Now, I guess if you machined another point for admission of that oil, but when you get in there, the funnel system is pretty good. It probably fills up pretty often, and it's always overflowing the whole time. Okay. I've had a lot of my old engines, including the Great American Race, and when I've really used them hard, I've gotten 20, 30,000 miles on them, and on turning the crankshaft, for example, which is what the question refers to, we're not half a thousandth that it wears. Yeah. The poor Babbitt bearings, the poor Babbitt is so soft. There's usually, you hear it or you take up the wear before you ever have any damage and scoring in the crankshafts.
Yeah. So I'm going to ask my own question just off of that. It seems that what I've been learning is that Babbitt bearings are actually good bearings. Yeah. They may be a little bit of a struggle to replace compared to what we're used to with insert bearings, but they actually do a pretty good job.
Well, an insert bearing is 30 or 40 thousandths of an inch thick, the whole thing. Yeah. Babbitt bearing, in lots of cases, is 1/4 inch thick. Yeah. So you have your shims on both sides of the cap. At some point in time, if you think it's too loose, or you have an oil pump on it, or you just want to take the pan off or the bottom half of the engine off and take the shims out and tighten it, see how much tighter it gets. I mean, something as simple as that. And the neat thing about Babbitt, it remelts. So even if you over tighten Babbitt within, a small range at least, it'll remelt and fit its size pretty well. It's pretty good material.
It's almost self-healing.
Well, kind of is.
In a way, yeah. That's interesting.
Really old Babbitt kind of chips off and kind of looks like little dirt clods, but modern Babbitt is pretty soft. Think of it as solder. I mean, as a soft solder, it's not much different than solder. Mm-hmm. I mean, in what you look at and what it feels like. Yeah,
yeah. Huh. That's pretty interesting. We're having a lot of good questions on lubrication here in these old cars. If an engine is relying on gravity for oil distribution, how is there enough of that for the oil to reach and lubricate the bearings and other internal components?
Well, gravity is only relying on that as it leaves the oil boxes, and all of them have oil boxes. You turn on the drippers. Yep. If you can put a little valve in, and some of the engines back then even had a little valve, which is basically a ball bearing that goes up with when you pressurize the crankcase and goes down and plugs a hole on the downsides and kind of sucks the oil in. It flows. I mean, you can tell if it's not flowing because the dripper is a small bottle, a clear glass bottle. And if it's half full, because you've got the drippers turned a lot, and then as you start running and running faster, it pulls it down faster. It seems to work pretty well.
Yeah.
Pretty automatically. So sometimes you don't turn the drippers on to watch one drip go from the top of the bottle through the bottom into the motor. Sometimes you turn the drippers on just to keep the level half full in the glass dripper bottle that you see. The different bottles on your dash.
Yeah.
And then as that half inch of oil goes down with high RPM, then your ball bearing valve is creating enough of a vacuum to suck it more in with higher RPM.
Yeah.
It does pretty well.
Yeah.
I've got 45 years of driving these things.
Yeah.
And they're not burning up engines.
Right.
And the rods are just completely by splash, and they basically have at the top of a rod, you know, where the bearing is in the rod, there'll be an 1/8 of an inch hole, but on the top of the rod, there will be a 3/8 of an inch kind of funnel, and that seems to be enough for 30 or 40,000 miles.
Wow.
It seems to be.
Yeah. Yeah. That's really cool. All right. Well, here's the next question. Why might two-stroke oil be considered superior for lubricating early engines like the ones we've seen here, particularly in terms of reducing clogs, smoke, and maybe even improving the scent?
I think it's a good idea.
Okay.
If you could get two-stroke oil that was thick, you know, so you kind of want to match the oil that they had back then, which is sort of a 30 weight fixed or 40 weight fixed. So if you could get some two-stroke oil that is that, and it was smokeless, but you can also buy that's not two-stroke oil. You can also buy oil that has it's smokeless oil and get it 40 weight or 50 weight smokeless oil.
Okay. So that's probably the preferred solution there then.
Yeah, you don't have to figure out, because most two-stroke oil is really thin.
Yeah, right. Because it's supposed to be mixing with the gas and all that.
Right, it's really thin.
Yeah, okay. Good question though. Okay, does the Sizaire engine incorporate valve oil seals? And if not, why might they be absent in its design?
It has valve gaskets.
Okay.
In the valve seat in the Sizaire is separate from the engine case.
Okay.
So I'll have that finished in a few days because I'm redoing that and I'm putting new springs on there.
Okay.
So I'll let you see that. So that valve cage and valve seat threads right out of the engine. And that's steel, not cast iron. The block is cast iron. Now the exhaust valve is machined into the cast iron.
Okay.
So the cast iron can take less of a spring to return that valve, and it gives more wear to the valve and more wear to the seat.
Okay.
But the valve pocket on the intake is almost perfect.
Okay.
In that case, that engine is different on the intake and the exhaust.
Okay. Not necessarily the same. Okay. I got a question about our Ferro.
Okay.
Were the head gaskets for the Ferro V8 manufactured by Olson's Gaskets in Port Orchard, Washington? And more broadly, where can one source head gaskets for these old vintage engines? I mean, that's a good question, I think.
You can call Eggy Machine. And the first time I took apart the Ferro engine 10 years ago, I called Eggy Machine, and they had some new old stock, 100-year-old head gaskets in stock.
No way.
They did. This last time, I called them again, and they, since I had bought the spares they had last time, they had another vendor that created them for us, and they sent them to us.
Okay.
So what company they used, I don't know.
Okay. But somehow they've got a resource.
They've got a resource, and there's probably other places besides Eggy Machine that has a resource also.
Yeah.
I know there's a place that's offshore that will make one of any head gasket somebody wants to make, one,
No
and
kidding.
do it within a month's time.
Okay.
So head gaskets aren't a problem.
Huh.
And also in my era of cars, most of them don't have head gaskets. Most of them are heads that aren't detachable, non-detachable heads.
Right. There's not even a gasket there to replace.
No, not even.
Yeah. Okay. It's a good question. All right. Is the Bugatti Type 22 featured in that episode? Is that a 16 valve overhead cam?
No. Every other Type 22 maybe in the world is running is.
Okay.
Mine is original 1913, mine is an 8 big valve head.
Okay.
So the 1913 ones were different, and whereas a handmade head and all, the ones for 1920 Type 22 were basically a LOX, and it was more of a mass production engine. And yes, they did have 16 valve heads.
Okay. Well, he enjoyed the distinctive sound of the engine, so
Yeah.
It's working, that's for sure.
Yeah, no, it runs really good.
All right, now this may be a fairly lengthy answer because I think there's a variety of answers depending on the car. Someone's asking, how is engine speed regulated in these early automobiles? Because the whole gasoline delivery, carburetor, variable cam, it all seems so different.
It is all different. For example, our cars with atmospheric valves, the delivery is based on what the valve is doing. You can't give it any more gas or any less gas. That valve is being sucked open and sucked closed. So it's deciding how much fuel. Our DD-Own, our 1897, doesn't run on fuel at all. No wet fuel. It runs on just simply vapors. So the only way it runs is it's got a triangular box, and that triangular box, and it's a foot diameter triangle box.
Okay.
It's got fluid in the bottom 1 inch, and then it's got all the fumes in the top. And as you pedal that race car, that race tricycle, it pushes those fumes, those ignitable fumes from the hexane and the heptane and the petroleum ether into the intake manifold, and it can only use so much of those fumes, and it's also got an atmospheric valve. On the Sizaire, it has no butterfly in the carburetor whatsoever. You have no control of the carburetor or what you think the carburetor is at all. It's simply got a venturi and a 4-inch long straw made out of bronze with 8 holes in it. So you're advancing the throttle on that, or advancing the gas in your mind by making the intake valve going from 50 thousandths of an inch lift to 600 thousandths of an inch of lift, 560 thousandths worth of lift. So when you floor it, you're just advancing the camshafts. You're not flooring it either. The engine itself is deciding how much fuel to draw up based on the vacuum that it's creating.
Right, you're opening the valve more to create more vacuum, so it's drawing it in through that.
And then all the cars that we have in here, the 20-some vehicles,
Yeah.
Are all updraft carburetors, and none of them have accelerator pumps.
Okay.
Because if they were downdrafts, they probably would fill up because the floats weren't that good back then. So they're all updrafts.
Okay.
And some of them are real elaborate with the idle circuit and mid-range and high speed, like the Bugatti. And that one really has an accelerator pedal, and a butterfly. But that butterfly isn't flat. It's a very, very fancy butterfly on that. They are all really different.
Wow. Okay. Yeah. And so that's a good answer.
Yeah.
That's how you control engine speed.
Yeah.
Let's see. Given that the 1903 Cadillac was the first production car with variable valve timing, what evidence supports the claim that these early models ran on methanol, considering the compression and spark advance challenges of that era?
Well, the Cadillac wasn't the first.
Okay.
Our 1898 Jean Perrin, which is an atmospheric intake valve on it, it has the atmospheric valve is controlled by the centrifugal weight system. And this is 1898, 5 years before the Cadillac.
Okay.
And it's got a wedge that goes underneath the opening of where the valve is on the intake. So the higher the RPM, the more the wedge comes out of it. So it's variable valve
Oh,
lift.
yeah.
So there's lots of engines and lots of companies that had different ideas to control valve timing or valve lift. Not valve timing, but Sizaire-Naudin is the only one, to my knowledge, that actually the only way to control speed, the only way in the world, was control it by your lift of the intake cam. That was the only way. No
Right.
centrifugal did it,
Yeah.
and no butterfly whatsoever.
Yeah.
So it really did it, and it had a real camshaft driving it.
Yeah. Wow. Yeah.
So, but a lot of them had, some even had a vacuum system like Winton's that would control valves to some extent.
Okay. Now, going back to the question about methanol, what do we know about the fuels at
Well,
that
the fuels
time?
came from three sources back then.
Okay.
So the three sources was grain, corn and that stuff, which is your methanol and your ethanol.
Okay.
It came from coal, and they made a lot of coal gas. And coal gas they called benzene lots of times. And then they also did distillates. They did distillates in Titusville in 1860s, 1861, 1862, and they'd have the refinery right at the oil well, and they'd come out with the distillates from oil with the hexanes, the heptanes, the petroleum ethers. So they had three basic families of fuels.
Okay.
And they could mix those together, and they also had a metal that started with P, and they knew that metal that started with P, I forgot the name, I didn't know that question you were going to ask it. They could introduce that into the fuels too and gain it on the octane. So they really had some choices on what their fuels were.
Okay.
And whether they injected them as fuel or injected them as vapor, they had all kinds of different ideas on that.
Okay. Well, sorry for the curveball, but you did well.
Well, but they knew that there's three sources. Some had a lot of vapor with the volatile vapor, and some didn't.
Okay. Yeah. Okay. Very good. Is there a temperature-based scale that correlates with the flow rate or the speed of water exchange in these early cooling systems?
It's not so much temperature, it's bubbles. So for example, in the Thermosiphon cars, without the water pumps, as the water heated up, it goes into the top of the motor,
right,
and then circulate to the top of the radiator, and as it cooled, come back down again. But it wasn't so much the temperature of the water that circulated, was the little bubbles that were created in it. So if you started an engine and it linearly went from 80 degrees to 180 degrees, from 80 to 120 degrees, there'd still be very little flow in the Thermosiphon system.
Okay.
But once you start getting it hotter and hotter, where the engine would start creating the little bubbles, those bubbles would accelerate that water.
Okay.
So lots of times a Thermosiphon engine gets kind of warm on its own pretty quickly and then starts cooling when the circulation happens. So a Thermosiphon engine car, you don't put your hand on the radiator in the first 3 or 4 minutes of it running, because you're not going to feel any heat. Because it's not really, even though it's linearly gaining heat on the engine, it's not making that flow happen.
Okay.
But 160, 170 degrees and up, when it creates those little bubbles, it starts flowing really, really great.
Interesting. Okay.
So it's more of that.
Yeah. All right. Good question. You helped me to learn something again. Here we go. Can you explain the design of the highly efficient combustion chamber of these early engines, particularly given that they work so well with surprisingly low compression ratios?
The Bugatti is the ultimate, and the Scripps Booth by Tess. They're both kind of almost like Hemi engines.
Okay.
They're both overhead valve. You had the combustion chamber just basically above the piston. You didn't have much more than that. They weren't hemispherical combustion chambers because it didn't have the spark plug in the top, but it had it in the side. But you had a combustion chamber not much larger diameter than what the piston was.
Right.
So those are really efficient. And most of the other early cars in here are L heads. So they had an exhaust valve here, an intake valve here, and over in this area here is where the piston was, and then the spark plug was somewhere.
Right.
Not very efficient. But for example, the Sizaire has an intake over the exhaust valve, so it made that valve pocket half as big. And then it's got a spark plug on both sides of that.
Yeah.
So, and it is twin fire, so it fires 2 spark plugs every revolution of the mag when it fires.
Okay.
So it doesn't have to wait for the flame to get from here to where the intake is and then where the piston is.
Yep.
It's pretty darn efficient, so you can use less timing.
Okay.
The ones that are the least efficient would be like the 1904 Mitchell, had 1 spark plug. It has, the intake and exhaust valve are both below and made a big valve pocket area. Low compression, you couldn't ever make it really much more compression. Not very efficient.
Yeah. Yeah. So the answer's not the same for every one of them at all.
Every one of them is different.
Yeah. Okay, we've got a lot of good questions on the Sizaire-Naudin. Here's another one. Does that engine utilize a floating wrist pin as it appears from the visuals?
It's got a C-clip.
Oh, it does. Okay.
On both ends of it, and the C-clip is tight.
Okay.
So the float is only a few thousandths of an inch.
Be very minimal float.
Right.
Okay.
But the wrist pin is at a bad design. It's an inch diameter.
Wow.
Okay, and it's a 5-inch piston diameter. So if you had a 5-inch piston in a vehicle, what kind of vehicle has a 5-inch piston? An airplane.
Okay.
So we had a couple airplanes, and a Lycoming 360, which is a 180 horsepower engine, has the same pistons in it as what our Sizaire has. It has 4 of them, and so it can only spend 2,500 RPM, or that's the maximum you're supposed to do in your airplane. So it's not high RPM because the piston is so large.
Right.
Its wrist pin, I'm sure, is not 1-inch diameter.
Okay.
I'm sure it's probably 1.5 inch diameter. I don't have one to measure, but I'm sure it's much larger.
Yeah.
Because when I was trying to find a spare wrist pin, there aren't any wrist pins that are 1 inch diameter that are 5 inches long. Because you're going to have some flex on any engine that would have that, which is an aircraft engine.
All right, back to the Ferro. Back to the Ferro V8 here. What component is attached to the crank journal located at the center between the middle cylinders? Is it a bolt-in slipper ring, given its offset design similar to a crank pins?
No, there's nothing there.
Okay.
It's a 2 main bearing V8 race car. 2 main bearings. One over here, one over here.
So hold your breath and hope for the best.
But it kind of balanced because it's got, two pistons or 2 rods on each of the journals.
Yeah.
So it's kind of like a motorcycle engine where it's got, the crankshaft isn't this long, it's only this long.
Yeah.
But it's,
do I recall it's a flat plane crank?
It is a flat plane crank too. That's how they made them, and it works fine. And they have a real oil pump and real galleys, and we're pushing 80 pounds of oil pressure in those 2 mains. No splash on that car, no drip on that car. It's 80 pounds of oil.
It's got a proper oiling system.
But also on the proper oiling system, it doesn't have any proper seals. So what they do is, to make sure that has adequate oiling and not a lot of oil pushing out the front nose cone of the engine or the back, they have an actuator. So at idle, as far as your foot's concerned, your oil pump has only got 10 pounds of pressure.
Yeah.
And as you accelerate your pedal, you're accelerating the carburetor, and you're accelerating the restriction in the oil line. So you only have 80 pounds of oil pressure when you're floored. So you could be going 5,000 RPM going down a hill with no gas on, or 5,000 RPM going up a hill, but your oil pressure going up a hill is going to be 80 pounds. Your oil pressure going down the hill, if you're coasting down the hill, say, could be 5 or 10 pounds.
Okay.
And it doesn't leak too much, so I think it kind of works.
Yeah.
But that's what they decided to do, and I've left it that way, and it works. But it just kind of looks funny.
Yeah.
because you can have the RPM spin the same RPM and have the oil pressure go 10 times more based on what your foot is doing.
Right.
So that's kind of...
Yeah, so I remember when we had that opened up, when you had it opened up and I came by, understanding kind of the variable valve pump or valve pressure was pretty interesting.
Yeah, it was their idea to keep it cleaner, and it makes it a pretty clean car.
Yeah.
And it's got enough lubrication, since they're only providing oil pressure for the two, which is all of them, main bearings, one on each end.
Yeah.
It works. And it's drip on all the rods.
All right. That's pretty cool. That's pretty cool. All right. Going back to the twin spark ignition, do the two, and I think you basically answered this, do the two fire fronts, okay, we're imagining, do they collide inside the chamber?
Well, they have to.
Somehow.
But the mag is opening the contact, so the two secondaries in the magneto fire instantaneously with each other, theoretically. Now, that's not right either, because as the spark plugs get more carbon built up or oil built up, I'm sure that timing changes somewhat based on what those spark plugs are seeing. So I think it might change a little bit back and forth, so that maybe in the actual running of the engine, one spark plug is probably going to fire, be more important to the combustion chamber firing, unless both spark plugs are brand new and super clean. Yeah. But it's better than having just one and have it oil fouled, and you have a single cylinder race car and it's not running now because you have no other.
So in the times you've driven it, you haven't sensed any detonation or anything that sounds weird from it?
No. And then also kind of neat is you could kind of tell a difference if we had two spark plugs and we had an L-head engine, because we'd have the intake valve here and we'd have the exhaust valve here. So we have a spark plug over here and a spark plug over here, and the primary spark plug would always be the one in the intake flow, because that's the gas that's going in. Mm-hmm. But in this case, for the Sizaire-Naudin, the intake valve is on top of the exhaust valve, and there's only about a half inch between the two of them, and the spark plugs on both sides of it. So you're not going to see a difference on either of those two spark plugs, because they're both firing the intake mixture perfectly. Right. So you're not going to see it. You're not going to be able to feel any difference. Yeah. Because that's a really nice design of the combustion chamber.
Yeah, that is really cool. Why are the electrodes in spark plugs consistently designed with a ball shape for the spark generation? Do you know what purpose that could serve? And I guess he's talking about the very old spark plugs where they kind of rounded electrode, or if that's the right word for it.
Every company did it differently. I don't collect spark plugs, but I still have 100 and some year old spark plugs.
You don't collect them, but you don't get rid of them either.
No, and some of them have a ball shape, like some are jagged. Some are a triangle inside the spark plug, and a 1/4 inch diameter for the electrode. Some companies were advertising this spark plug will last 800 or 900 years. And if you have a ball shaped electrode, you're not going to deteriorate it much. If it is sharp edges, you're going to start deteriorating that electrode much quicker. Right. And if you have a big triangle inside there, you're not going to deteriorate that at all. It's never going to heat up. It's never going to heat up to detonate. Probably the very worst spark plug design from the back era, which is where you had basically an electrode and it was sawed off flat. Yeah. And probably a really good one is the one that was ball shaped. Okay. Because it would not come from the same spot at any time on the fire. It'd come up from anywhere around it. Yeah. And their very best designed to last forever was the big triangle. The giant electrode on the inside. Okay. By our 1897 DDO still runs the same spark plug as it did 127 years ago, and still runs perfectly on the original spark plug.
That's awesome. That's awesome.
I think if you asked Thomas Edison or Mr. Tesla or Benjamin Franklin's things, all of their sparks back then, when the spark could go anywhere, because they were firing sparks in the atmosphere, they were all round and it was pretty, the spark from it. Because it would come and kind of roll back and forth.
Yeah, yeah.
So that's what's in our mind for really early things.
Yeah, right.
So that's...
Yeah. Okay. Well, that's really interesting. Okay. Okay, now here someone is challenging. I don't know where he gets this from. Those plugs are not original. The original plugs had a square drive and not a hex drive.
Well, every automotive spark plug I've ever had, and I have 100 different kind, are hex.
Okay.
I've got a few really early airplane plugs, and they are square.
Okay.
I have 2 of those, but nothing that I have on any motorcycle or car or trike from 100 and some years ago were anything but hex.
So he may have, he's a bad source of information on that part. We'd have to, okay, we'll put it this way. We would love to see references, pictures, or information that calls out square plugs on cars.
Sometime I can bring out 100 different plugs, and you can. I have Thomas Edison plugs. I have Tesla plugs. I have some of the earliest ones in the world.
You know, I want to take you up on that and do a spark plug video sometime.
We can.
That'll be
and
good.
there's other collectors in the world that would have 500 different ones of them.
Sure, right. Yeah, that's not the focus of your stuff, but
and I have it because I like to be able to run it everything. When I go to a Concours, it's kind of neat to show up with everything real, every single piece.
Right. Yeah.
But if a total loss engine, and I'm going to go on a 1,000-mile, 1-week-long tour, I'll have a few original plugs, and I'll also buy some new, modern, clean plugs. So if I get them oil filled, I can just on the road change them quickly and get back on the road again.
Keep going. Yeah. Okay. Very good. Did Aviation adopt the dual magneto ignition and double spark plug technology from early automotive designs, given the similarities and their massive electrode plugs?
Well, what Aviation didn't do that some of the race cars did, the race cars would have one mag, a few of them, much newer than 1906. Our 1906 is a 1905 Bosch with twin secondaries and one primary to fire 2 spark plugs.
Okay.
But all early airplanes had twin magnetos.
Okay.
And you would time the magnetos separately to be the same point as a redundant system.
Right.
So the race cars were not done as a redundant system so much, but Bugatti had 2 spark plugs or 2 mags also, but not twin fire mags.
Okay.
Twin fire is a pretty special thing.
Yeah.
Twin fire spark plugs for race cars, that's pretty cool and pretty rare.
Yeah, very good.
Yeah,
very good. There are currently some multi-electrode plugs that have like 3 prongs, as he's calling them. Dissimilar metal corrosion would lock those in the head sometimes. So someone's had a struggle with those in the past, especially when there's both aluminum and steel engine, you know, different metals and different engines. Do you have any comments or experience?
I use anti-seize on the aluminum engines, aluminum heads.
Okay.
And it seems to allow me to take them out.
Mm-hmm.
And there's probably some anti-seizes that will operate even at higher temperatures.
Yeah.
But most of the plugs in our old cars, the heads are pretty darn thick, so they don't really get that hot on the outside. Whereas maybe a real racing car might be a pretty thin head. I haven't had any trouble getting spark plugs out.
Okay.
And then lots of times the spark plugs are in bronze. So we have big pucks that are threaded into the engine, into the head. And those, why are they big pucks? Because the pucks, you take them out so you can take the valves out.
Well, right.
And the spark plugs are threaded in those, and those pucks are bronze or brass. And that always releases, always.
Yeah.
Once in a while, those will be steel too, but more often than not, they're brass or bronze.
Yeah. Huh. That's interesting. More than one person made this observation. I don't know, we're kind of jealous. Like, why is it that electrodes on modern spark plugs aren't replaceable? Like, you've had rebuildable spark plug, I think we talked about.
Well, there were no auto parts stores back in 1902, 1903. There was no dealerships. There is no transportation system to get your car to you. There's no gas stations yet.
Right.
So it's you and the blacksmith.
Yeah.
You and the blacksmith. So they better make it so you can take them apart. And then to take apart, they were told lost engines. Almost all of the engines from the very early were told lost, which means the oil got in the wrong places a lot. You needed to take those spark plugs apart. Everybody had kerosene in their house for their lights and their lamps. So you just poured your kerosene in there, cleaned it. And they made cars back then for a lifetime.
Right.
You know, everything you're seeing in here is 115, 120, 125 years old. And the manufacturers back then, and all my original owner's manuals said this car should be good for life.
Right.
Well, if you look at the cars and motorcycles in here, they're still running perfectly like they did 120 some years ago.
Yeah.
And they still do.
Yeah. Yeah. So it was a completely different mindset all the way.
I'm not going to make you a new car, you know, in 3 years. What? I spent all this time making you this one? Right. Same thing about the mansions and things. They made them out of bricks and blocks, not styrofoam and stucco and chicken wire. I mean, they really made things to last forever. Yeah. And they used the right materials that would last forever. Yeah. Not a cheap material, the correct materials.
Right. Right.
So that's just what the mindset was.
Yeah. Since electricity follows the path of least resistance, what's the purpose of having 3 ground electrodes on these spark plugs? Isn't that really just redundancy?
But they also burn away sooner or later. So if you're back to the spark plug lasting for a few hundred years, the electrode does burn away. And also the ground lead does burn away or can burn away. It only is going to fire to one spot. Every revolution that it fires, it only fires to one spot. Right. The path that is the least resistance, like the question says.
And I'm just recalling, I think a lot of times it's called the ground strap, I think, is what that other part.
Yeah, they called it all kinds of things in the last 100 and some years.
Yeah.
But it's only going to fire to one spot.
Yeah, and that's all there is to it.
Yeah.
Okay. Fair enough. Do you know when the first automotive transmission was developed?
Well, my 1898 has a transmission.
Okay.
And the transmission has no engine case. It's made out of about 11 spur gears. And underneath the back seat of the car, there were these giant spur gears that are spinning. And when you shift it in the 3-speed on the column, as you shift it on the column, you move the gear that's on the countershaft that engages to the spur gear. And just like the clock towers they had in the 1600s and 17 and 1800s, there's no oil in those gears. These gears, and they're selectable, have never had any grease or oil on them, and they're still perfectly fine. And going down the highway, which is say 45 mile an hour, in my 1898 car, it's quiet. The gears are quiet. And they're straight cut spur gears.
Really?
Yeah, I'm sitting on them, and yes, it's a seat and cushions and leather and all that, but it's still pretty darn quiet. So that's 1898. My 1897 Didion trike has a differential in it, but only single speed. But in 1899, they too had a 2-speed transmission. That's 1899. You know, they had tractors the year before, the 5 years before, 10 years before. They had traction engines. They knew about gears and spur gears and that kind of stuff.
Yeah, the whole railroads and trains and all kinds of industrial revolution things back in the 1800s.
They had gears. I mean, they didn't have a transmission in first gear in a train, second gear, third gear.
Right.
But they sure had gear drive, all kinds of things. They had spur gears back in the 1600s in the clocks.
Oh, right.
It's the same gear.
Yeah.
Same gear.
Yeah. Rhea liquid clutch. We're back to the Sizaire, I believe.
Yeah.
How do the components lock together during operation to transmit power if there's oil in there? How does that work?
You have a variable spring pressure.
Okay.
So you have a foot pressure of about 50 pounds on the clutch. So the metal disc is pushing on the other metal dish.
Okay.
And it's tight. It's a machine surface.
Okay.
So even if it was going to slip, the oil that's got in between those two burns away very quickly or pretty quickly. There's a constant source of more oil in the reservoir when it opens again. But when it's closed, there's no oil really getting in there.
Okay.
So it it locks. One interesting thing about clutches, a lot of these have cone clutches in them.
Mm-hmm.
So a cone clutch was a very efficient way to have a flywheel. You had a center of a cowhide in a conical shape that would kind of wedge inside of a conical shaped receiver in the clutch.
Mm-hmm.
And sometimes, like our big Renault and our big Knox, big engine cars from back 110, 15 years ago,
Yeah.
we would have stiction on the freeway. So we'd be driving the big Renault, the 1906, and go down the freeway for 20 miles, say, in a rally. And then there's an exit, and you push on the clutch pedal, and you have stiction where that conical shaped leather-backed cone would stick in the flywheel, and you couldn't break it loose. You couldn't get it out again.
Oh my God.
So what that meant is you didn't put enough needs foot oil on that leather as a release mechanism.
Uh-huh.
So just the opposite from what the question is. Most of the time you needed more oil to make it release.
Okay.
You never ran it dry. And the clutches, the leather clutches, whether they're on a flat plane or a conical plane, they would last 40 or 50,000 miles.
Wow.
And the metal-to-metal ones, the Bugatti is basically metal-to-metal,
Mm-hmm.
but it's got a bunch of wafers that are metal-to-metal, 10 of them. So as you engage it, it's nice and smooth. You know, it's metal.
Wow.
But it's smooth.
Yeah.
The Sizaire only has a big flywheel and a big clutch plate, metal-to-metal, but the total loss system has oil go through the center of the crankshaft, and it kind of oils into that bath. So the two discs are spinning in a little bit of oil bath on the bottom.
Uh-huh.
So when they're open, they get a nice fresh mixture of oil.
Okay.
But once they cinch together and move a teeny bit, it locks in place.
Huh.
They work fine.
Yeah. Could you discuss the use of chain gears in some of the earliest automobiles and explain the challenges or risks associated with using chains in the drive?
All the big powerful cars and even a lot of the early cars, the drive was by chains.
Okay.
They didn't have a drive shaft that was capable of sustaining the torque that these engines have.
Okay.
So these aren't high horsepower cars. These are high torque cars.
Yeah.
So you couldn't have a shaft. Plus they had no real form of U-joint in the earliest times that could last for a while.
Right.
And then they created U-joints, and they had no bearings in the U-joints, but they would have 4 squares of bronze on a spider with 4 little rods on it, and then that would allow some U-joint action to happen. But what they needed back then too, they needed to lock the rear end to the transmission. They needed to lock it. So they couldn't have a drive shaft without having the supportive rods to keep the front end or to keep the rear end moving in the same plane to the transmission.
Right.
So that was just natural to have drive chains on the early cars and drive chains on the early powerful cars. And the drive chains for the early powerful cars, that lasted into the teens, like the Simplexes, the Mercedes. They still had drive chains almost out of my era.
Yeah.
Because that was the only thing you could take the horsepower, take the torque.
Yeah. So and they obviously worked okay.
Yeah. So drive shafts was a modern thing, and only the little cars kind of had drive shafts first.
Okay. Yeah. Okay. So in the context, we're going to go back to fuel delivery on these early cars. How do you define a carburetor? Because you've discussed, these, I know we talked about a fire tube before and all the updrafts and different things. So what makes a carburetor versus other things?
Well, a carburetor would have several different air and fuel jets in it, in my mind. For example, the Stevens-Duryea has literally a 1.5 foot long tube. It has a butterfly in it. It has a butterfly in the intake manifold. But then it has a 1.5 foot long tube that's got a pipe going into the float bowl, and it's sucking fuel up. But if I take apart the Stevens-Duryea, which is a fabulous car, very valuable, extremely expensive car back at the time, there's not a piece of it that's a carburetor. There's no air orifice jets. There's no gas orifice jets. You have a float bowl.
Yeah.
But every other a piece that you're looking at, it's not a carburetor piece.
Okay.
There's no small area for the carburetor to get blocked with fuel. You know, I guess in the Venturi, the tube coming up from the fuel, I guess you could have the fuel sucked a piece of grit in the bottom of that.
Yeah.
But there's no jets, there's none of that stuff. It's all based on the vacuum that the engine has.
Yeah.
And the Sizaire has even less than that. It has no butterfly at all. A big Venturi, long Venturi, and one bronze straw in it.
Yeah.
The Bugatti, I have a racing carburetor. I have a Winfield carburetor on it. Now that's a real carburetor.
Okay.
That has an idle circuit, mid-range circuit, an adjustment for both, and a high-speed circuit.
Okay.
So that's got pieces in it.
Yeah.
You know, it's got 50 pieces. The other carburetors in here might have 1 or 2 pieces. Oh, not 1 or 2, but 5 or 10 pieces, including the screws.
Excellent. All right. So if you want a real technical description beyond what Alan just gave you, you're just going to have to get on Google or something as far as that goes. But these it is a part of the fascination of these pre-World War I cars, is they're all so different in how they figured out fuel.
But they figured out that you could just suck fuel by a vacuum through a Venturi and a straw. Yeah. And there were variations of that.
Right. And they didn't have to all be in one place, which is what we think of maybe as a carburetor. They were scattered around the car.
Right. And then the carburetor, like in the early Wintons, they were 2 foot long. But the big Renault is the carburetor. It's not the carburetor manifold. The carburetor is a couple foot tall.
Wow.
It just is.
Yeah. What's the estimated value of that rare 1906 Sizaire, and how did Alan acquire such extensive knowledge about these scarce vehicles?
During the early 80s, I wanted the very best cars produced in the time to do the Great American Race.
Okay.
I did not want to get a Model T and modify it to go 50 or 60 mile an hour. That's just against everything in my being.
Okay.
So if we're going to race a car that's 100 years old, 110 years old, I wanted to research and find out what the cars they looked at to race back then at the time. So I built my knowledge base by investing in 8,500 books and magazines over a 10-year period of time. I virtually have everything published from America, the UK, France, and Germany from 1895 to 1915. So I could put myself in first person. I could understand what they wanted back then. I could read all the racing reports back then, all the times that they did on the races. And I just put myself in that position to get those cars. And that's why the cars in here are pretty rare cars. They're not Model Ts, which is a common car. You know, these are what people really wanted back 4 generations ago, because they ran and did the performance on their own. You know, I just love it when I have a 1906 car with a single cylinder, and the manual, the 96-page manual for racing says it should go 48 mile an hour at 1800 RPM on a single cylinder. That's cool.
That's very cool.
You know, because most of the non-race vehicles at that time that had a single cylinder, for example, or even a 2-cylinder, would go 25.
Right.
And here's something going unbelievable speed for the time.
Yeah.
So
it's called immersion and doing it. So the Great American Race, you mentioned that, and that is a significant part of your automotive background. What were kind of the specs to enter a car and run it?
It had to be 50 years old.
Okay.
Or older, and you had to pretty much run the car like it was. You couldn't really change a lot. Okay. You know, so you and then because of that, I didn't want to change a lot, and I didn't want to put overdrives in. We were allowed to do that kind of stuff, and we were allowed to do things on the brakes. I didn't do anything on the brakes. I didn't put overdrives in it. I really tried to stay within the boundaries of what that car was capable, and then procure, you know, good race cars and restore those from body off, frame up restoration.
So even the 1980s, though, a 50-year-old car be the 1930s, you don't have much around here that's that new.
I hide those. Where I keep the lawnmower, there's a 1931 that's a fabulous car, you would think.
Yeah.
But I keep it in with the lawnmower because it doesn't fit this room.
Right. Fair enough. Someone was looking at the top of the Sizaire one single cylinder engine and noticing what he calls the 3 solid copper nuts holding the engine together.
Yep.
It's like, are those really the primary components holding it together, or can you explain what that is?
Those 3 copper nuts, which are 1.25 inch hex, are only keeping the valve cage in for the intake manifold.
Okay.
So that's all it's holding. It's not holding the head together, the water jackets, or anything else. It's holding a valve cage that's only got a 50-pound spring.
Okay.
It's keeping that in position.
So it's actually overbuilt. It's not really doing that much.
It's not really doing that much.
Okay.
They're pretty and they're beautiful,
right?
But they're not really doing it very much.
Okay. Okay. So another question, and we're getting close to the end of our questions for today.
Okay.
How in the world do you maintain your cars in such clean, pristine condition when they're 100 years old and they have to lose oil? And how do you do it?
The main thing is I don't have to work on them too often because I always run them on alcohol-free fuel.
Okay.
So alcohol-free fuel means that if you point to any car in here within 5 minutes, we can be driving it and running it down the road.
Yeah.
So if I had put pump gas in these cars, and it might be a year since I started that one or 2 years or something.
Right.
Immediately, if you wanted to go for a ride, I'd have to take the carburetor apart. I have to do all this kind of stuff.
Right.
So by having that, by using smokeless oil in lots of cases, by using synthetic oil that cleans much better than high zinc oil cleans, and then I commonly, because you come and other people come, I drive them. And this last week, I drove the Bugatti, I drove our Delage, I drove the 1931, and I'm not going to say what the brand of that is, which is fancy. I drove, that's the ones I drove this last week.
But the last week, there's 3 right there.
3 of them.
Okay, so you keep them moving. That's part of it. And then clean them up when you put them away, I guess.
Yeah, and I have a list when I put them away on what things I noticed the last time, so I don't just pull it out of storage and it's a perfect car. No.
Yeah.
If I put it in here and I didn't do the checklist.
Okay, that's awesome. This is the last question of the day.
Okay.
What information can you provide about the rear view mirrors? Now he's talking about the featured car, and I guess I'm trying to figure out which. He didn't reference which car he's talking about, so I'm not sure which car that is. But he thinks it resembles the 22 Model T. I don't know if that's a clue on which mirror he's thinking of, but I know you don't have a Model T here.
Well, they had mirrors back then. The Marmon Wasp was the first time that a mirror was publicized at the time.
Okay.
Because it was all of the race cars back in 1910 and earlier. You know, they always had a riding mechanician, and then they would have the driver. But the Marmon Wasp decided to have no riding mechanician.
Okay.
So he installed a rear view mirror on the Marmon Wasp car that did the Indy 500, and he ended up winning. But they had mirrors back 200 or 300 years earlier than that.
Sure.
And lots of times they weren't mounted to the car, but the same beveled mirror, they just kept them in their hand.
Oh,
they
really?
needed it.
Yeah.
So they didn't necessarily mount it somewhere on the car. But so mirrors have been around forever.
Right.
But they didn't come. They didn't come on any car from the factory 1915 and earlier.
Okay. They were like accessories, or
they were accessories, and then you could buy them. A lot of these cars have original mirrors. An original mirror to me was older than 1920, and maybe it's on a 1909 car in my case, or 1908 car or 1912 car.
Yeah.
And maybe that mirror is still 4 or 5 years newer than the car.
Yeah.
But I drive all my cars. They're all street legal, and you have to have mirrors on them.
Yeah.
That's not to say that my wife doesn't carry sometimes a mirror in her hand too, because where you mount them on these cars, since there's no wide bodies on them, wide fenders, and when you're both sitting in that pretty small seat, you can't see around yourself to see out anyway, because you might be the highest point in the car.
Yeah. Yeah. So,
and a lot of them don't have windshields.
Yeah.
So you deal with the mirrors, and they had mirrors back then, And in fact, one of my awards from 1903, one of the awards that they won from the Gordon Bennett Cup included a mirror that you would hold, and it was all beveled and beautiful. And it's in the 1903 box, the presentation box. And then it's got the Gordon Bennett race in silver on the outside of it.
So
the mirror was in the box.
Pretty fancy deal.
Yeah.
That's good. Well, Alan, thank you for taking the time to answer all these questions.
Well, you're very welcome.
Fantastic.
Thank you, Barry.
All right. And thank you for sending your questions, for making your comments and watching our videos, and continue to follow Alan's various projects. And we look forward to seeing you on the next one.